So this video is on template classes. So templates are actually really handy. So let's take a look at a function that we're all used to. So let's say that I want to create a void function, and I'm gonna call it swap. And we all know the swap one. We want to swap the values of two variables. And so in this case, I'm gonna do a swap of two integers. And of course, in order for us to do that in a function, if we want the variables that are passed to the function, we have to pass by reference. So I'm gonna pass A and B by reference to the swap function. And we all know this one. I just say int temp is equal to A, and then A is equal to B, and then B is equal to temp. And now I am able to swap the values of two integers. So let's say we want to do that for characters. So I'll create a void function. I'll call it swap again, because of course we can overload it. And this time I'm going to make them characters. And so we have character A, we have character B, and I'm going to say character temp is equal to A is equal to B, and B is equal to temp. All right, and so now I'm able to swap two characters. All right, and so now if I want to swap two doubles, then I would say void swap, and I would create double reference, and it will do A, it will say double reference B, and inside that function we will say double temp is equal to A, and A is equal to B, and B is equal to temp. All right, and so if I want to do that for floats, then I would create a function called void swap, and I'll say float. And by this time you probably are bored, right? Because I'm writing the exact same code. The only thing that is different is that I'm changing the data type, right? In this first swap function, I have integers. The next one I have characters, and the last one I have doubles. But if you notice, the algorithm is exactly the same. I am creating a variable called temp. I'm setting it equal to A. I'm setting A equal to B, and then B equal to temp. So if I needed to do that for all the data types, I can be writing the exact same code over and over again, right? So that's where it's great to have template functions, because since we notice that we're doing the exact same thing, why don't we just write the function once, and then we can use that same exact function for any data type. And that's what a template allows us to do. So to create a template, we use the keyword template. And then inside of our carrots, we use, we're gonna introduce a new data type, and we say class T. And this T can be anything. It can be any name, right? You're just creating a identifier. But it is common practice to just use T for template. And so what this T is this is going to replace our data type. So we're going to use T as our data type instead of integer or char or double, right? And so we'll write the function the exact same way. So I would say void swap, and then I'll just say T reference A and T reference B, and then I'll say T, because that's our data type, temp is equal to A, and A is equal to B, and then B is equal to temp. Right, and so all I need to do is write that function once. And then if I go into my int main, now I can just use that function, and it doesn't matter what variable type I use. As soon as I pass that variable to my swap function, whatever the data type is of that variable will take place for t, right? So I can say, I can go in my main and I can create character A. Let's make it equal to the letter A. And I can say B is equal to the letter B. And then I can create some integers. Let's say int, I'll just call it A1 is equal to 1. And I'll say B1 is equal to 2. And I can create a double. I'll call it A3 is equal to 2.5. And A4 is equal to 3.6. Right? And now I can pass all of these variables into the same swap function, and it will perform the swap function to all of those variables, even though my swap function does not have the variable types for all the functions. And so that makes us able to, it makes us not have to rewrite functions over and over again. As we saw before, our swap function does the exact same thing no matter what the data type is. The data type is really not important, right? The algorithm is exactly the same. So if we say template T, then we don't need to rewrite that swap function. T is actually gonna adapt to whatever data type is passed in those variables. So since I'm passing A and B in their characters, then T is now gonna turn to a character data type, and it's gonna perform the algorithm as if the variables are characters, right? So we're not limited, right? We could also create let's think about a function maybe like pow, void pow, right? If we want to get the power of a number, we can say T A, and we can create a new class called SB, right? And so if I do that, then I need to use the keyword template. And then I'm just gonna define class T and also class S. And so now I'm saying that my template can take two different variable types, right? And so in my function, I can say, I can just create a variable, and I will call it S, right? And I'll make this be my result, and I'm gonna say that is equal to A. And then of course for pow, if we're gonna do A, and this is probably a really bad example, but I can use my for loop, and I can just write whatever the algorithm is to make to implement the power function. And then if I go into my main function, I can create a variable int, and I can call it num, and I can set that equal to 2, and I can create a variable double, and I can set that equal to 3.7. And then I can call my pow function, and I can pass in, I'll call this E. And I can say, num E, and it will adapt the data type for num, and it will change the T to that one, since num is the first parameter passed to the function. And since the second is S, then S will adapt to double, since I'm passing E as the second parameter. And so now it will perform my algorithm, and it will replace whatever S is as double, and it will replace whatever T is as integer. And don't get me wrong, that doesn't mean that I'm limited to having two different data types. I could still pass two integers to that function, and all it will do is just make both S and T integers. And so that's how we can do template functions, and we can do that with as many data types as we need to. So we're not limited to one, we're not limited to two. If we need to have 5 different data types templated, we can do that. We just need to make sure that we defined 5 different class names. All right, so this video is called template classes, right? So this is a way that we can do it, functions, right? This is a way that we can template a function. This is functional programming. But what if we wanted to do it for a class? Well, to do it for a class is not much different. We do the same thing. We'll say template class T, and then we'll define our class. So I'm just gonna call this my class. So we'll say class, my class. And now anything that we want in our class to be templated, we're gonna say that's T. So let's say that our class has an array. Let's say we have a private array inside of our class. And this is gonna be what holds our data, right? And so since we don't know what type of data my class is going to need, I'll just create an array of type T. And now I have an array. If someone wanted to use my class with characters, then they can do so. Someone wanted to use it for strings, they can do so. Because whatever we define, when we declare our class, whatever we say T is, then it will create an array of that data type. All right, so, but we don't have to template every variable, right? So if we are going to template a class that uses an array, for instance, we might also want to have a variable that keeps track of size, right? So I still would want to make that an integer, right? Because when we keep track of array size, it should be an integer. So I can still put integers inside my class with no problem. It's only gonna change whatever I define as T. That's the only thing that will be changed. All right, so let's say this is a very basic class. It's not really doing much. Now let's say we actually want to instantiate a variable of type my class. So if I go into my main function, and I want to create a variable of my type of my class, and I want this array to be declared as characters, for instance, then the syntax is like this. I will declare my class, because that is the class name, and then inside carets, I'm going to put character, right? And so now that's going to tell my class that anything that is defined as T in my class, we're gonna make that characters, right? So if I create a new variable and I just call it my object, now I created a new object and it has a private member variable of type character for 100, an array of size 100. So now I have a character array of size 100. I could also create a new variable. I can say my class, and I can say string. And I can create a new object, my object 2. And now my object has an array of character, and my object 2 has an array of strings. And so it's important to know the syntax. If you make a templated class, you have to put the data type in the declaration. When you're declaring the object, you have to declare what the templated data type will be. All right, so that is how we would declare a templated class. And you've seen this before, right? You've seen this. You've definitely seen this before when you do something like this: vector int. Right? V. Vector is actually a class that was defined as a template, and their T would be whatever data you put in these carets to make that vector now an integer vector. All right, so let's talk about when we want to actually define functions, right? So this is our class declaration here, right? This is our declaration. How about when we want to define functions? So let's say I have a function here in public, and I have a function, and let's call it, um, t. I want to return t, and I just want to say get, value at, right? And basically that's going to give me the value at the index given from my array. So I say int index. So basically what this function is going to do is that I'm going to pass an integer, and then it's going to give me the value from my private array at whatever integer was passed to my function. So because my array is type t, if I want to get the value at an index, that means that I have to return type t, right? Because the array is an array of type t. So it's going to return type t. So the way we define that function is a little different than what we're used to. So we always have to put template class t before the function, just like we did with our swap. And we're going to give the return type of our function. And since I said get value at is going to return t, I'm going to return a t. And then remember, I'm defining this for my class, so I need my class scope resolution operator. So since my class is called my class, I'm going to type in class, but it's a template class, right? Just as we declared our class this way, I'm going to have to put my template inside the class scope resolution. So I'm going to say my class t, and I'm going to use my scope resolution operator, and then I'm going to put the name of my function, get value at, and then I'll put in my parameter. And basically this function would just return array at index. And let's say I wanted to, the same would go with function parameters. If for whatever reason I had a function that returned a t, I have to put another template class above my function, template class t, and if it returns a t, let's say my function is called my function. I need to put my class scope resolution. So my class t, scope resolution operator. I'm just going to say this is called my function. And then let's say this took a parameter of type t. Then whatever I pass to this function, whatever the data type is, will take, this t will take that data type, and this t as well will take that data type. So templates are really based of what you pass to it. Whatever data type you pass to a template is what that template class name will actually take for your functions. All right, so let's talk about friend functions. So remember, friend functions are not a part of the class, right? If I had let's just create a new class, template class t, and we'll just call this class another class. All right, and so if inside my class I have a friend function, right? So let's say I have, let's say the insertion operator. So of course we declare that as a friend, and then we have our O string. reference. And of course, we have operator. And we have our parameters. I'm going to put our parameters right here. So the first parameter that we have is the OString reference. We'll call that out. The second one is a constant, and it's going to be another class. But since this is a friend function, it's not part of the class, then I have to pass in the data type here, right? And let's just call this function A. So I have to pass in the data function. So we would think, okay, maybe we should just pass in T since we templated our class as T. But remember, we templated another class as class T, right? The T is a template for another class. But as we know, a friend function is not part of the class. So the friend function can't take on class T. Because when we define template class T, we're defining it for this class, another class. But a friend function is not a part of the class. So that means that if we need to pass in another class as a variable, then we need to give another template for our friend function. So we can do that very easily by just creating a new template, and we will give another variable for our class. In this case, I'm just going to call it S. So now I want to put S here, and I only wrote another here, but I think you guys should all know that this is another class because it has to match the class name. So let me just fix that. Const, we'll say another class S. And so now we have another class that's templated, and then we have to create a template for our friend function because the function is not a part of the class. And since it's not a part of the class, it's not going to take on the class T that we defined. So we have to create a new class name. And so in this case, I called it S. And so now I can put whatever functions I need to inside my class. And if I wanted to create templated functions in my class and their member functions of my class, then I do not need to put the template keyword anymore because the template keyword that we have here is for my class. So I can just go ahead and create a function here called T my function, and it can have whatever variables it needs in here. I don't need to rewrite template class T above the functions inside my declaration because this template class keyword here, it applies to anything that are member functions or member variables of another class. And I know I'm repeating myself, but just to reiterate, this template class T applies to all the member functions and member variables of my class. And since a friend function is not part of the class, then this template class T will not apply to this function. And that's why I have to create a new template for this friend function in order for it to work. All right, and so that is pretty much how we do template classes. Thank you for watching. And the secret word is going to be Barbie.